Components and block diagrams. We have HC05 Bluetooth to transmit the signals from and we have 5-volt relay that we connect our valve to it on and off. This is our valve of 220 volt connected with directly 220 AC. This is ultrasonic sensor SCSR04 echo and ground. This is TIVA TM4C123GH6PM. This is our block diagram. In this block diagram, firstly we show the ultrasonic sensor. Ultrasonic sensor transmits the ultrasonic wave and it received by other end, and we calculate the total time and multiply by the speed of the ultrasonic sensor move. This is our step 1. Step 2, it's connected with the TIVA Launchpad and our Android app. HC05 is connected to TM4C123GXL TIVA and Android app. We connect the Bluetooth. We shown in this process in working, and Android app give us the value of what is the depth of the water at that time and how much tank is filled, and control the Bluetooth using Android app using the transmitter and receiver. So if command is on, the electric valve flow the water, and if command is off, it move it, and also calculate the ultrasonic sensor, give a distance. ये है हमारा कील. हमने अपने प्रोजेक्ट की कोडिंग की है C लैंग्वेज में. So we start it. Firstly, we added the header file tm4c123gx6pm.h. Then we add some C language files std in statlab stadio. This includes the printf statement. Some is going to print string statement, but this is not important. Our important is the peripherals of this code, interfacing of HC05, ultrasonic sensors, and algorithm. So we start it. First, we define a function of GPIO port initialization. This will initialize the ports that we used in this project. Then is delay. Delay is the timing delay to transmit and receiving the signals, datas, and something else. UART5 we use here, so we change it UART5, but I name it UART7 before I don't want to change it because all the program will be changed. So I name it UART7, but actually I use UART5. Bluetooth read, Bluetooth write data, Bluetooth write string on my Android app using the Bluetooth. U-in32T measure distance is used to measure distance of ultrasonic sensor. U is used for an unsigned value of time because it gives something in a negative value, but we use the positive value as a unsigned. 32 is for the 32-bit time. A0 capture, we use the timer 0A. You can also use timer 1A or 2A according to your choice. Delay microsecond is used for ultrasonic sensor. How much is time, trigger time to rising of the loop, rising of the signals, and dropping of the signals. Next is I defined a character C1 as a string because the Bluetooth write only data the strings. It can read in a string and integer, but it can be write in only in a string statement, so we use a C1 here. Next is this character C1C. U-in32 time in unsigned 32-bit, and distance is also in unsigned 32-bit. We character a message that sends a message on a message. One is also used, but it's same relate to the message. Before coming to the int main, first we come to down for the port initialization, so you will understand. First is GPIO port initialization. In this project I use the port A, port P, and port F. So I use this 23 0 multiplied by 23. You can calculate easily. GPIO port F lock R for the port F unlock. For the port A unlock, port F clear register is 0 multiplied by 1 F because it's defined are the pins of port F and port A0 multiplied by FF. Directions, giving the direction, I used the port F. I used the ports PF4, PF3, PF2, PF1. So I use 0 multiplied by 1F. Port F, I also digital enable 0 multiplied by 1F, 0 multiplied by FF because I defined all the pins enables of port A and port F. Okay, next we come to our next target. This is U in 32 measure distance. This is used for the ultrasonic sensor. U in 32 last edge. This edge, last edge mean when the ultrasonic sensor is sending the signal, this is the last edge, and when it getting the register, this is the this edge. So we defined it as a unsigned 32 bit. So downward is GPIO port A data R. I want to tell you that our trigger pin of ultrasonic sensor is attached to PF4 and echo pin is attached to PB6. So first in the ultrasonic sensor, it is rule that first trigger down the ultrasonic sensor, then trigger up the ultrasonic sensor, and then trigger down. So first we trigger down, so we it's equal to the 0, and delay microsecond or 2 seconds. You can use it at your own choice. And GPIO port A data are then the trigger pin high. So we port A 4 to the high, and delay microsecond 10 second GPIO port at then trigger pin low. So first we low the trigger, then high the trigger, then low the trigger. And then is the while statement. While statement is used that ultrasonic sensor continuously reading the value. So timer 0 we use ICR. R first clear the interrupt. Interrupt is very important to clear in the time, because if the interrupt exists in between, it cause some fluctuation in the values. So first we capture it, then while timer 0 raw interrupt sense. Raw interrupt sense is also used to capture. If in the capture in the while loop, मतलब कि लूप तब तक चलती रहे जब तक इसके दरमियान कैप्चर की वैल्यू 0 नहीं हो जाती। ठीक हो गया, तो ये तब तक लूप की वैल्यू चलती रहेगी। ठीक है, देन वी डिफाइंड द इको पिन, वी कनेक्ट एज आई से बिफोर द इको पिन वी कनेक्ट PB6. So we connect if the echo pin is exist, then the calculate the last edge value, mean ultrasonic wave, how much value time, how much time it to take a transmit the value. And the next is the save also the state where capture the pin and calculate the distance statement, that find the difference between the distance. This is the total time the ultrasonic sensor transmit or receiving the signal. Next portion is why timer is 0. Here we define the timer 0 capture. System timer RC timer defined by 3, because we use here two timer, T timer 0 and timer 1. Timer 1 is for the delay microsecond, and timer 0 is used for the timer 0 capture. So we define it as 3. GPIO port B, we use the GPIO port B and port A as I discussed before, the ultrasonic sensor. So we take it to the 3. GPIO port B initialization and GPIO A initialization, same as I discussed before the GPIO initialization. Timer 0 control is before the disable. First CFG is used for the 16-bit timing, so I use the 4 here. Timing module is up counter, down counter, periodic module. This is so I calculated and write it to 0 multiplied by 17, and at the last CTL is 1. It shows the enable the interrupt, I mean timer. Delay microsecond is also used. Timer 1 as discussed, the CTL CFG for loop is defined to a microsecond delay in the ultrasonic sensor waves. UART7, I think I defined the name UART7, but I really use the UART5. So UART5 has a pins RX5, P4 and P5. So I defined the port E as I discussed in the port initialization. UART7 function defined. It is the peripheral. Before is the ports initialization of UART. Then the peripherals. Peripherals means we defining here the UARTs, the peripherals. So we use the RX UART5. So we defined it 20. And CTL IBRD calculate. How to calculate IBRD? This is very easy method. I think you know FPRD 11 0 multiplied by 68 10 IBRD 104. It's easy. You can we use the 9600 baud rate. 9600 we use 9600 baud rate. So we calculate it is 16 divided by 16 megahertz, so it will guess 104 multiplied by 16 divided by 16 mega. So we come to downward. It is the Bluetooth read. Bluetooth read actually read the data that we given from our Android to Bluetooth device. So I define a corrected data here, while FR it is used for the receiver buffer. Until the receiver buffer is not full, it will not work down. It collects data from UART5 DRR, and again return the data that we pressed like a button from Android app. White Bluetooth write is used to write data. So we declare a TX buffer here, and the next is the Bluetooth write string that is used to write the string that ultrasonic sound. Ultrasonic sensor is transmit the data to Bluetooth. That write tank is how much tank is the full. So this function is used for this purpose. Why delay? And delay time is the delay. We come to our main function here. We call the UART timer GPI initialization. While one time it will measure the time and the distance. If distance greater than equal to 8, because that we use our tank is 8 centimeter, I approximate. If it greater, we show the tank is overflow and full. Else it will show the how much tank is a full. And if I press if I press the button on Android, it will show valve is open, and press the next button, it will show the valve is on or off. And this is this thing is a relay that we connect to PA2. So our valve is connected to VA2. This is our Tiva. We connect it using the model. We connect the wires with it. This is small breadboard wire, so we connect the common of VCC and ground here. This is the small valve that eject the water from this tank, and this is the switch that connect with the valve. This is our valve that we connect here. This is our small tank that flow the water from here to this. This is our main tank. This is the ultrasonic sensor that will tell how much tank is full and how much tank is empty. This is our Bluetooth, and this is our relay, and this is the complete wiring of this project. Tiva. So I connect it to my PC. So the Tiva is on, Bluetooth is blinking, and relay is also on. So तो अब हमने अपना वाल्व इसका कनेक्ट कर लिया। तो अब मैं डालता हूँ इसमें पानी। ठीक हो गया। तो मैंने इसमें पानी डाल दिया। तो अब ये यहाँ से यहाँ मूव करेगा जैसे ही मैं वाल्व को ऑन करूँगा। तो जैसा कि आप देख सकते हैं ये यहाँ से यहाँ मूव वाला, और जैसे ही मैंने वाल्व को ऑन किया तो पानी यहाँ से यहाँ मूव करना शुरू हो गया। और जैसे ही मैं वाल्व को बंद करूँगा ये पानी दोबारा अपनी यहाँ से यहाँ फ्लो करना। ये वाल्व कनेक्ट है हमारा। So now we discuss our 4 tasks that show in the previous whiteboard. Firstly, as usual, we define the TM4123GS6PM header file, then steady.h, that time.h, because we use the timer library here, because in the last class of previous whiteboard we use elapsed time. So for the elapsed time we use the timer library in C language. Firstly, we define the 1 millisecond count because 16,000, it's because 16 megahertz frequency, and we use a 1 milli to 16 multiplied 10 raised to power 16 multiplied 10 raised to power 6 multiplied 10 raised to power minus 3 will get 16,000. So in hexadecimal it gets 0 multiplied 3 E80. Next we define some parameters like GPIO initialize, disable interrupt, strict initialize, enable interrupt, write string. So and here we declare some variables: count milliseconds, send data 0, pf 0. Initially we get it as 0. So elapsed time is in a character form because UART is deal with the string, not with the integer, so we get it. So next is this white system timer handler initialize. We counter value, counter की जो value है वो आपके पास increase होती जाएगी. सो एस प्रिंट एफ जो है वो हमें वैल्यू देगी कि कितनी देर में हमने अपना जो टास्क है वो परफॉर्म किया है. लैप्स टाइम हमें बताएगी. अगर इफ़ काउंट एलिमेंट इज़ ग्रेटर देन 1000, अगर उस 1000 से ग्रेटर देन वैल्यू हो जाती है तो वो दोबारा वैल्यू आपके पास 0 पे आ जाएगी. एंड वी यूज़ हेयर द एज ए रेड लाइट टू परफॉर्म our task that it is show working or not show working, and send data 1. GPIO initialization, we use here the port F here, so we initialize the port F. And next is GPIO initialization in interrupt initialization in port F, because we use here the port F. First we interrupt sensor, then edges, and then the both edges, then clear register, and then interrupt masking. So interrupt sensing is used for 1 because we use the S trigger. If we not use the S trigger, we get it as 0. Edges is a high level trigger respectively, so we get it 0. Both edges, not both edges, so 0. ICR clear interrupt, for the clear interrupt request we use a 1 1. IM interrupt masking is for PF0 and PF4, same as interrupt clear. NVIC nested vector interrupt, so PRI7 we used, we show it in the table, so we get it. And next is enable value is also get for the port F. For the port F30 for the GPIO port F, GPIO port F के लिए enable की वैल्यू हमारे पास ऐसी होती है. तो मतलब कि हमने इसके पोर्ट्स को इनेबल कर लिया कि बिट जो 30 हमारे पास होगी उसको हमने 1 दे दिया, बाकी ऑल ऑफ 0. सेम इसी तरह हमारे पास NVIC की वैल्यू होती है, और NVIC की वैल्यू भी हमने टेबल से फाइंड की है. सो वी डिड इट. एंड नेक्स्ट वी गो GPIO handler. If GPIO port F RIS R0 मल्टीप्लाई बाय GPIO F हैंडलर को हमने डील किया कि अगर हम रॉ इंटरप्ट सेंस अगर हम उसके बटन नंबर PF0 को दबाते हैं तो हमारे पास PF0 प्रेस की वैल्यू 1 हो जाए, और अगर हम PF4 को दबाते हैं तो उसकी वैल्यू PF4 प्रेस करने की वैल्यू हमारे पास 1 हो गई, जो कि हमने ऊपर इनिशियलाइज़ किया था 0. नेक्स्ट इज सिस्टिक इनिशियलाइजेशन. सिस्टिक को यहाँ इनिशियलाइज़ कराना होता है NVIC के ज़रिए, रिलोड वैल्यू करके, करंट वैल्यू करके, और कंट्रोल करके. कंट्रोल वैल्यू सबसे पहले तो डिसेबल होती है, देन वो अनेबल हम कर देते हैं उसको, गिविंग द वैल्यू ऑफ रिलोड वैल्यू इज इक्वल टू पीरियड -1, पीरियड इज 1 मिलीसेकंड हियर, एंड द करंट वैल्यू इज ऑलवेज 0. इनिशियलाइज द पोर्ट UART0 हमने इनिशियलाइज़ कराया. देन UART0 के पैराफेरल्स को हमने इनिशियलाइज़ कराया, डेट वी डिस्कस इन आवर प्रोजेक्ट. So UART send character, and getting the character UART0 send the character that sent to putty, and getting the character that sent from that we get from the putty, and using the UART. Write string is used to write the what is perform and how much is seconds to perform our task. Main function, we call all the function in main. So when we press the button PF0, it will show writing on the putty PF0, and it also tell us the time, how much time it take to pressing the button. And when we press PF4, it will show how much time is pressing the PF4 button. So this is our complete code of 4 questions. First is this SysTick handler, next is GPIO initialization and UART initialization, then is our UART, and 4 is working and time lapsed.